Good morning and afternoon, class. It's Miss Fowler. So this is the first page of your packet for today. If you can, please go ahead and put your name, today's date, which is the 7th. And this is going to be page 6. So I need you to please put a page 6. That way I know what page number it is. Notice it has holes punched in. So that means it's going in your binder. Okay? The only thing that's different about these equations is notice that we have a fraction next to the variable. That technically still means to multiply, but I'll get to that more on that in just a minute. So before we start doing that, we need to understand that we need to find the reciprocal of a fraction. Remember, reciprocal just means I'm taking that fraction and I'm flipping it. So the numerator becomes the denominator and the denominator becomes the numerator. So right here, if I have 1/3, if I just flip them, this now becomes 3/1. If I have 5/7, it should become 7/5. So if I have 2/5, I want you to take a few seconds just to try this one out. All right, so if I have 2/5, my reciprocal should be 5/2, or 5/2. I hope that makes sense, because what we're about to do is going to have to use the reciprocal. So what we have is this next left section of the paper. We have 3/5 times t equals 6. So it's already telling you the coefficient of t is 3/5, because remember, if I have a coefficient next to a variable, they're side by side, that means to multiply. But before we multiply anything or divide anything, we've just got to understand how to set this problem up. So the reciprocal of 3/5 should be 5/3. Ooh, that was terrible. Sorry, y'all. I should write that a little bit closer. Hard to hold up a phone and do everything at once. All right. So remember how if I have a division problem, and you don't have to write this down, I'm just showing you. If I have 3/6 divided by 2/4. Okay? Remember, when we divide by fractions, we actually multiply by the reciprocal. So I would still have 3/6, but then I would times it by 4/2. That is the exact same thought process that we're going to be using when we divide by fractions for our one-step equation. So we understand that the reciprocal should be 5/3. And whenever I multiply by the reciprocal, if I do it on one side of the equation, these two automatically cancel out. But since I've multiplied by this one side on the equation, I would have to multiply by 5/3 over here. Okay? So our new multiplication problem would become 6/1 times 5/3. So when I solve that and I multiply straight across, I'm actually going to move my answer because I don't know how to use paper apparently. Okay? So when I multiply fractions, I go straight across. So 6 times 5 should be 30. 1 times 3 should be 3. But am I done? I sure hope you said no. Notice that says simplify. This right here is just a division problem. I can divide both of them by 3, or I could put 30 divided by 3 in the calculator. And when I take my handy dandy calculator and I type 30 divided by 3, I get 10. So my final answer for this problem is 10. Okay? Let's try the next one. If I have 2/7 times t equals 8, I still have a coefficient next to a variable, which means to multiply. But remember, when we divide by fractions, we actually multiply by the reciprocal, which is why I have this up here to remind you, multiply by the reciprocal. All right? So what I'm going to do, which I didn't have room over there, is I'm going to draw my scale. Okay, so I'm going to have my scale, and then I'm going to multiply by the reciprocal. Remember, I need t to be by itself, so I have to multiply by this reciprocal. So take a few seconds, think about what the reciprocal would be. It should be 7 over 2, because remember, we want these to be able to cancel each other out. So when I multiply by 7 over 2 on one side, I have to multiply by 7 over 2 on the other side of the equation. But notice right here I have a whole number. If I have that whole number, what denominator can I put underneath it to still make it a whole number? It should be 1. So from here, I'm going to multiply straight across. When I multiply straight across, 8 times 7 is 56. 1 times 2 is 2. Remember though, this is just a division problem, so let's see if we can simplify it. So I'm going to grab my calculator again. I'm going to draw 56 divided by 2, and I get a new quotient. I get 28. So whenever I solve this work and I simplify, t is actually going to equal 28. Okay? Now I can check this work by replacing the variable t with the original equation. So I'm going to check my work over here on the side. Okay, so I'm going to have 2/7 times 28 over 1, because that's a whole number, and I hope that it's going to equal 8. So I've got to bring my calculator out, and I've got to do 2 times 28. So my numerator will become 56. Then my denominator is 7 times 1, which I hope we know is 7. But whenever I divide 56 divided by 7, I hope that it's going to equal 8. So I'm going to take my calculator, I'm going to check my work, and in fact it equals 8. So 8 equals 8, and that answer is correct. So the only thing that's going to be different when I use fractions is instead of multiplying one number, I have to multiply by its reciprocal. I just got to flip that fraction over. No other steps change. We still set up the scale, we still find the inverse operation, and we still solve and check our work. So I'm going to try this one example with you, and then I'm going to let you try these ones on your own. Okay? So first thing I'm going to do, draw my scale. Next thing I'm going to do, I got to multiply by the reciprocal. That just means take this fraction, flip it over. So when I multiply by that reciprocal, I should get 7 over 1. And these go bye-bye, because I used them. So if I do it on one side of the equation, I have to do it on the other side. Now, what number can I put under the 3 to still make it the number 3? Hopefully you said 1. And when I multiply straight across, 3 times 7 is 21. 1 times 1 is 1. So when I simplify this, 21 divided by 1 should just be the number 21. But notice I'm not done yet. Look what it says to do. Check your solution. Check your work. I cannot stress out enough about how many times I need to tell you, check your work. All right? So when I check it, I'm going to have the variable t, and I'm replacing it with the number 21. So I still have my exact same math problem, but now I'm just replacing the variable with the number 21. Now you're probably thinking, Miss Fowler, why in the world did you put a 1 underneath it? It's a whole number. I can put a 1 underneath it, so I did, because fractions I multiply straight across. All right, so 21 times 1, or excuse me, 1 times 21, I can't read today, is 21. 7 times 1 is 7. And remember, this is just a division problem. 21 divided by 7 is just a division problem. So I'm going to take my calculator, I'm going to put 21 divided by 7, and it equals 3. So whenever I check my original equation, 3 equals 3, and I'm right. Okay? What I want you to do is I want you to try these ones. There's only 7. I need you to try your best on them. I need at least 3 of them done. I need you to attempt them. Skipping this page is not an option. For those of you that have not been doing your work lately, you might want to catch up. You might want to get on track. Remember, my grades are due next week. So let's make sure that we're working hard. Let's make sure we're doing our best. The other pages are fairly self-explanatory. SpongeBob messed up on his work. You tell me what he did wrong. You show me the right answer. That's front and back. The maze, there's backside. The maze is self-explanatory. This is where you start, you figure out the answer, and then you have an end way. I don't mind if you color this while you work on it, as long as I see some work. Then the last page, this one's front and back. Okay, remember, you figure out the answer, then you get to color the picture. So I don't mind if you color as you work, but I need you working and I need you doing your best. So I hope that you have a marvelous weekend. I hope you're safe. I love you very much, and I'll see you next week. And on the weekend, I will upload a picture of me graduating into the Google Classroom too. All right? Bye.